So now instead of talking about rotating two curves around the x-axis or a line parallel to the x-axis, that would be any horizontal line, we're going to be talking about rotating around the y-axis and any line parallel to the y-axis, which would be a vertical line. For these, we're now going to be looking at our equation with our radius in terms of y. All right, so that means if we've got a standard function equation, we need to have it equals x in terms of y. All right, so that means when I'm looking at these equations here, I have y equals positive negative square root x. I need to solve that for x by squaring both sides. So I've got x equals y squared. Then I have my second equation, y equals x minus 2. Solving for x, I've got x equals y plus 2. All right, so these are going to be the equations I use because in the problems right here and that follow, we're rotating around the y-axis or lines parallel to it, those vertical lines. So bearing this in mind, I'm going to label my graph when I come down here. So I've got y plus 2, right, and I've got, what did we just say? Y squared? Yeah. Yikes. All right. So we're finding the volume when we rotate about x equals 7. So x equals a number means x is the same everywhere on that line, which makes it a vertical line. So imagine this vertical line here. We're rotating around it. All right, so that means we're going to have, if I sketch real quick, the mirror image of this graph. All right, and this is going to have rotated, so obviously not perfect, or these circles would be perfect, all right? But you're going to have cross sections like that. So our inner function here, the one that's closer to that x equals 7, is going to be the line, right? So this is my inner. My outer is going to be that sideways looking parabola function, right? Or y squared. So for outer, we use capital R. For inner, we use lowercase r to denote what we've got going on. So our volume, pi times our, now we're looking in terms of y. So we're looking at what are those y values that bound my area. So I've got C and D, -1 and 2. All right, just a tip. We're using y values because we're looking at our equation in terms of y. We're integrating with respect to y. So 2 to -1, we've got our outer function minus our axis of rotation, so y squared, minus our axis of rotation is 7 squared. Then we do the difference of our inner function, y plus 2 squared dx. Now we have to expand this. So I've got pi times the integral from -1 to 2, y to the 4th minus 14y squared plus 49 minus, use the parentheses so I remember to distribute that negative. So writing it out once more, when I distribute that negative, I'm going to flip the sign on all of those. So it's going to be minus y squared minus 4y minus 4. Combine your like terms. Got y to the 4th. -14y squared minus y squared is -15y squared. Then we've got just -4y all by its lonesome. And then we've got 49 and negative 45. 49 and negative 4, which is going to be positive 45. Still learning to speak here. And I did make a minor mistake. These should all be dy's because we're doing with respect to y. Sorry about that. All right, so now we integrate. So that means we have to make our powers 1 greater and divide by the new one. So I'm going to have y to the 5th over 5 minus 15 y to the 3rd over 3 minus 4y squared over 2 plus 45y. We're looking at the value from negative 1 to 2. Simplifying that, I've got y to the 5th over 5 minus 5y cubed minus 2y squared plus 45y. Whoops. What am I doing? All right, now we substitute in those values. So I've got 2 to the 5th over 5 minus 5 times 2 to the 3rd minus 2 times 2 to the 2nd plus 45 times 2. And then our other bound is negative 1, so we substitute that in. So negative 1 to the 5th divided by 5 minus 5 times negative 1 cubed minus 2 times negative 1 squared plus 45 times negative 1. All right. 2 to the 5th is 32. 32 fifths. 2 cubed is 8 times 5 is 40. 2 squared is 4 times that is negative 8. 45 times 2 is 90. Then we've got negative 1 to the 5th is negative 1. So we got negative 1 fifth. And then we've got negative 1 cubed, which is negative 1 times negative 5, positive 5. Negative 1 squared, positive 1 times negative 2, negative 2. And then 45 times negative 1, negative 45. So let's combine everything here. We've got negative 48 and 90, which is positive 42. And then we've got negative 38. We want those over 5, so times 5 over 5, times 5 over 5. All right, we're getting somewhere. So I've got 32 fifths. Whoops, why am I writing equals? Plus 240 fifths plus 1 fifth plus 380, 190. All right, I'm pretty sure I did all that multiplication right in my head, but feel free to correct me. I do make mistakes sometimes. All right, we got 240 and 190, that's 430, and 431, 463. So 463 over 5 times pi, or 463 fifths pi. All right, so go ahead and give the remaining 2 problems a go, and have a good day, folks.